Hello everyone, today we are going to be talking about continuously compounding interest. All right, you've already, hopefully in the textbook and in the videos from my math lab, learned about compounding interest, where that interest will compound, say, every month or every quarter, every 3 months, something like this. Well, let's think about that interest compounding and building up instead of every month. Well, it could be every week. Or instead of every week, well, let's make it every day. Or instead of every day, better to compound it every hour or every minute or every second or every millisecond. And that's the idea behind continuously compounding interest. So your interest, it's compounding essentially all the time. Okay, infinitely many times. Over infinitely small compounding periods. And you may be asking yourself, well, if we let those compounding periods get so smaller and smaller and smaller and smaller, so teeny tiny, how are we ever going to compute this? And it turns out that there's a really, really nice formula for computing this, and it involves the irrational number e. And let's remind ourselves a little bit about e. Okay, so e is just like pi is a specific irrational number. E is a specific irrational number. It is 2.71828 and keeps going and going and going and going. Okay, and it should be noted here, you never want to round off before ending a problem, and you never want to round off e. So whenever you're doing these types of problems, you want to always use the e button on the calculator and wait until the very end to round off. This is a lot easier if you've got a calculator like a graphing calculator or something where you can do multiple operations at once, or at least use the answer key. But it's possible on just a scientific calculator. You just gotta puzzle it out a little bit more. Okay, let's go ahead and think about making this into a formula. Okay, so this nice formula that we're talking about still has familiar variables. So F stands for future value, right? The value after the time and interest has built up. P is the principal, so the amount you start with, or the present amount. R is your interest rate, always written as a decimal, and T is the amount of time in years. All right, and our compound interest formula is the future value is the principal times that irrational number e raised to the RT. So here's our formula, and let's always remember we use the E key on the calculator here. Let's go ahead and use this in an example. Okay, if you put $2,300 into a savings account earning 1.85% compounded continuously, what is the balance after 2 years? All right. So keyword compounded continuously tells us we're going to use this formula here. And let's go ahead and list out our variables, fill in what we know, and see what we don't know. Okay, Well, first, $2,300 is what we're putting into a savings account, our starting amount. That's our principal. 1.85% compounded annually, or continuously, move to a decimal, that's 0.0185. That's our little r, our interest rate. T is the time in years, and we know it's 2 years. And F, future value, well, we don't know. That's what we're looking for. What is the balance after 2 years? All right, so let's fill in our formula. F, we still don't know, is the principal, 2,300, times E raised to the R times T, 0.0185 times 2. Well, we always want to start inside out. Okay, so interior, as far as we can go, is that 0.0185 times 2, which is 0.037. So what you're going to do on the calculator to compute this, you're going to compute this part first with the exponent e to the 0.037 using your e key on the calculator. And then whatever that answer is, multiply it by 2,300. And if we do that, what we get, rounded off to 2 decimal places, since we're dealing with dollars and cents, is 2386.69. which is not that much higher than what we started with, but that's to be expected with a low interest rate like 1.85%. If you did this and you got something like $5,000, that's a red flag, right? If you just think about if that fits common sense, well, $2,300 isn't going to reach $5,000 in 2 years with a low percentage rate. So it's always a good idea to think to yourself, does my answer make some kind of sense? Does it fit with what's happening here? And this answer does. And that is it for today.